all those technical difficulties. I believe you can hear me. So with that, my name is Asad Bajwa. I am the EMC Lab Director at Met Laboratories. Today we are going to talk about the Wi-Fi Alliance certification program. Most of you, I believe, are well familiar with what the Wi-Fi Alliance is. It's an organization formed to help coordinate the their maximum efficiency. So this alliance has a lot of programs which are based on IEEE 802.11 standard and the derivatives of this standard. So we'll look at some of those. However, the main focus would be to talk about the certification process as it relates to your products as a manufacturer. A brief introduction, as I said, the Wi-Fi Alliance is a responsible body or organization who takes care of the certification side, and after the successful setting based on the various Wi-Fi Alliance programs, Wi-Fi Alliance allows its members to put the Wi-Fi certified trademark on the product. Talking about the Wi-Fi, again, I believe 99.99% people are very well familiar what the Wi-Fi is or what the Wi-Fi stands for. In a nutshell, Wi-Fi means wireless internet connectivity to the computing devices, call it a laptop, tablet, smartphones, even machine to machine. The Wi-Fi connectivity is becoming more and more popular. So in a nutshell, Wi-Fi, when we talk about Wi-Fi, what it means is that the wireless internet connectivity. So continuing on, I mentioned briefly in my introduction about the Wi-Fi Alliance. As I stated that the Wi-Fi Alliance programs are based on IEEE 802.11 standard or series of the standard. However, as we all know, IEEE is not a standard writing organization. It's not a testing organization. Their major role is to do the standard writing, which they are extremely very good at. As part of their Wi-Fi related standard, 802.11 is the key standard, which has different flavors, which basically relates to different technologies. For example, 802.11a will be 5 gigahertz technology, which we know we talk about all the time. B will be the relatively older technology, and I have a brief chart, a couple of slides down, I believe, which shows a summary of what those different flavors of IEEE 802.11 are and what kind of different speeds they offer if we just take the connectivity speed as a parameter to compare them. That said, coming back to the Wi-Fi Alliance, the way the Wi-Fi Alliance works, to get an approval or certify or have your product certified, a manufacturer would have to first become the member of the alliance, pay their dues, be actively involved, and to become a member, you have to be a legal entity in United States, etc., etc. So you meet all those requirement criteria to become a member, and at that point, you as a manufacturer become eligible to have your products go through the certification program. So I will elaborate that as we go through. Okay, a quick note, just as a reference to the folks who are less familiar with what the 802.11 IEEE standard talks about. In a nutshell, it was meant with the intent to develop the MAC and physical layer, or PHY, we commonly refer to as specification for wireless connectivity for fixed, portable, and moving station in a local area. In a nutshell, what it means is that any computing device, whether it's a mobile, whether it's portable, whether it's moving or not, when it's intended to connect to a wireless network, so this set of standards from IEEE 802.11 will be defining the specification, and based on those specifications, these products will be designed. Okay, as I mentioned earlier, this particular slide simply do a comparison of different flavors of IEEE 802.11 standard. If we start with 802.11b, which works at 2.4 gigahertz, and most of us who've been in industry for some time have seen this early Wi-Fi protocol, which offered the data rates up to 11 megabits per second. If we scroll down, I mean, A was obviously at 5 gigahertz, which offered 54 megabits per second. If we scroll down, we see down the line came a next improvement, Wave of Hope, which was 802.11g, came out in 2003. Again, it was at 2.4 gigahertz. However, it offered 54 megabits per second. With 11H, they added the dynamic frequency selection, which is the DFS, the protection against the radar signal, which was a requirement from the governments around the world. Talking about the FCC in USA, they had mandated this requirement, and manufacturers have to build in the protection there to handle the DFS signals. Next comes another very popular flavor of 802.11, and a large number of people still in the world use today, the 802.11n, which came out in 2009, which will give you connectivity both at 2.4 and 5 gigahertz, and it offered much higher data rates, roughly around 10 folds compared to your 11A, if I do a comparison with that. And the data rate offered was 450 megabits per second. And right after 2012 came 802.11 AC, which operates at 5 gigahertz, and the data rates were obviously very significantly higher, and it operates at 1.3 gigabits per second, which is much higher and much needed data rates for the computing needs today, the way the people are been using the devices, tablets, smartphone, etc., to watch videos, especially the high definition videos, etc. So this much needed data increase was needed there, and 11AC is significantly helping. Without going much deeper into the technology, 11AC relies upon MIMO-like topology, where it would rely upon the different spatial streams, in other words, reflection from different structures, to capitalize upon getting much higher speed, basically. If I would continue on, so again, I have a few slides here which may sound very basic to the folks who are seasoned with the 802.11 technology and the Wi-Fi Alliance, but I had them in there just for the interest of the folks who would be new to the Wi-Fi Alliance, and they would want to learn about the basics of the Wi-Fi Alliance. So I have a couple of slides there just for the folks who are being introduced to the technology today. So very quickly, I would not spend too much time on these slides. Very quickly, a couple of definitions there which come in picture each time we talk about the Wi-Fi Alliance, the approval, and the Wi-Fi in general. So we hear the word stations and access points all the time. In a nutshell, a station would be a device which will connect to a Wi-Fi network. So if I try to differentiate between stations and access points, so all the devices which connect to a Wi-Fi network will be considered stations. However, an access point will be a special station which will offer the bridging capability, so that the other devices which are part of the network, they can connect to the outside world or the connected wireless network through the access point. So without access point, you may not be able to connect to the wired network. Continuing on, very often when we are talking about the Wi-Fi like network protocols and the network, two more definitions come in picture. One is called ad hoc mode, another one is the infrastructure. So let's go quickly look at the picture for the ad hoc mode. In the ad hoc mode, as I mentioned earlier, the devices are the stations are talking to each other in peer-to-peer mode. So they are communicating with each other. They can communicate multiple devices in the network. However, they are not connecting to anybody outside the network or connecting to the wired network. In the infrastructure mode, they will be a single access point for sure, but in some of the cases, to help increase the speed and to improve the efficiency, there could be multiple infrastructure, multiple access points in the infrastructure mode where the devices, mobile stations, whether it's a computer, whether it's a smartphone, whether it's a tablet, etc., your smart television, they will be connecting to the internet through an access point in your home, or if you have multiple access points. So that's a very commonly used topology in the Wi-Fi networks today. Here is an example of infrastructure mode. A very common example for, I mean, I would say it represents perhaps 99% of our homes today, where there will be an access point, like you can see in the middle, which will be connecting to typically through a wired connection through your service provider to the internet, and then all the devices or users within the infrastructure network mode, whether it's a laptop, whether it's data storage, whether it's a tablet or a smartphone, all of those would be connecting to the internet through the access point. So that makes it an infrastructure mode, which is a typical representation of it's a typical representation of the network used in our homes today. Next, I want to jump into the certification side. When we say our device is a Wi-Fi certified, what does that mean? Wi-Fi certification, as we all know, is not a regulatory or legal requirement in North America, Europe, or any other part of the world. It's an industry standard. It's an industry requirement, if you would want to call. Having the Wi-Fi certified logo on your product definitely gives you a marketing edge to your competitor as a manufacturer, and speaks a lot about the quality and performance of your product. So you do not need to go prove that your product meets the essence of the applicable IEEE 802.11 standard if your product for that particular technology would have gone through the Wi-Fi line certification. So as I briefly mentioned at the introduction, that to get the Wi-Fi certification, a manufacturer would have to first become the member of the Wi-Fi Alliance, pay their fees, etc. And at that time, when you're ready to have your product go through the certification process, you go log into the Wi-Fi Alliance online portal, and through that portal, you would initiate the certification process and go through the steps to achieve the certification. So allow me to highlight those steps in next few slides, and at the end, if you guys will have some any questions related to this process, I'll be very happy to jump into that. Okay. Well, it may be prudent to briefly go over these definitions, because they will come in picture when we talk about the certification process I started. So let me very briefly go through these definitions of the different kind of certification, and in the next slide we will go to the exact steps it will take to achieve some of these certification mentioned on this slide. So new certification, as the name specifies, means you have a brand new product and it has never gone through Wi-Fi certification. So obviously this will fall under the category of new certification. And where these definitions come in picture, all these definitions come in picture when you folks as the manufacturer log into the Wi-Fi Alliance online portal, and you are initiating an application to go through the certification. So during that process, you will have to make a choice whether you are going for a new certification, additional certification, so on and so forth. So additional certification would mean that your product has already gone through certification, and it has already have certification for one aspect of your product. Now you are enabling another feature or technology within your existing device, so that, for example, you may have a certification for 802.11 N, and now you want to enable 802.11 AC, so on and so forth. So you will have to go through additional certification for the other technology you are enabling within your device. Recertification comes in picture when you are making certain modification to your product, whether it's a firmware change or a hardware change that would require additional, or what I should say, that would require recertification. Dependent product certification comes in picture when a manufacturer would like to incorporate a pre-certified Wi-Fi Alliance pre-certified module in their product. So at that point, the manufacturer of the product will have to go through what we call dependent product certification. Finally, the transfer comes in picture when the original certification was done by one of the Wi-Fi Alliance members, and you guys as a manufacturer are purchasing the device and making some cosmetic changes to the equipment which do not relate to the firmware, hardware, etc. So that process will be called the transfer of the certification. Now, this is where I would like to walk you through the actual steps. My apologies, I'm still going through some issues, still under the weather. I hope you can still understand me. I'll do my best to speak as clearly as I could, but I'm certainly having challenges due to some issues I had. Okay, so talking about the certification, as I mentioned a few times about the portal, when you guys become member to the Wi-Fi Alliance, you are given access to the member area onto the Wi-Fi Alliance page. There is a public area, there is a member area. For the member area, you would have to become a member, pay their dues, etc., and then you gain the access, which essentially means you have a login ID and password to go to your member area. When you go log into the member area, you have the option there from what we call the certification portal to initiate a new certification request. So during that certification request, you will be providing detail about your product. You will be providing detail about technology your product is using. You will be providing detail about what the device does, etc., etc. At that point, based on the kind of certification you are looking for, from one of the pull-down menu, you will be given the choice of the ATLs, which are approved testing laboratories by the Wi-Fi Alliance program, who can perform testing to that particular certification program. And you will make your pick based on either your previous business experience or based on your discussion with the sales team, etc. So you will make your choice of the ATL you would want to go for, and you will continue through the completing the process there, meaning the application through the certification process. Once you make a choice of ATL, ATL gets notified through the Wi-Fi Alliance portal system. ATL will receive an email. ATL will coordinate with you about the schedule. So based on your discussion with the ATL, you guys will talk about the financial arrangement, meaning they will provide you a code estimate, the timeline to perform the testing, etc., etc. So you guys work on the schedule, and after the schedule has been firmed, you have provided all the hardware, software, what's needed, the testing begins. After the testing is completed, based on pass and fail, if the product passes, it goes through the next step, which is the certification step. If there's a failure, God forbid, then you continue to coordinate with the ATL and see what could be done to address the problem which your device had during the certification testing. Okay, so another part, what you need to provide as part of the certification process to the ATL would be 2 representative samples of the device you would like to test, all the relevant software, firmware, any necessary documentation or instruction for ATL to operate the device. Some simple example would be the IP addresses of the device, any password, login information, etc., etc. After the testing has been done, the ATLs are required to submit the results to a Wi-Fi Alliance within 1 business day. so that at that point the Wi-Fi Alliance folks will designate a technical person to review the results, and if they find results satisfactory to their need, they will take the next step toward the certification. If they had any questions, they will reach back out to the ATL and or the manufacturer. Okay, as I mentioned, after the results must be submitted back within one business day to the Wi-Fi Alliance. Otherwise, results are deemed not usable, and in many cases, you will have to go through the testing again. However, sending the results within one business day is by and large the responsibility of the ATL test labs, basically. So the next steps through the certification process would be that the Wi-Fi Alliance will designate a qualified engineer to review the results. Within 48 hours, they will complete their review. They will make sure the member is still in a good standing, meaning they have paid their dues, they are active member, etc., etc. At that point, if all the requirements are met after the testing, the Wi-Fi Alliance will send you an email as a manufacturer to notify that your product has been approved for certification. They will provide the details, how to use the Wi-Fi mark. They will email you the certification of interoperability, etc., etc. So the process would be within 3 business days after the testing. If all the requirements are met, the Wi-Fi Alliance will, based on the test result, will email you the certification along with the instruction how to use the Wi-Fi logo, and there will be quite a bit of variety based on what is the nature of your product, what technology it uses. So you will be accordingly notified which logo will be more appropriate for your product. This is again a very brief summary of what I just described. If I just walk you through, and I had a link included so that from the members page, you guys can quickly access if you have not been familiar to go to the certification portal. So you can click this link there and reach out to the certification portal. And one more step I would like to mention, that once your product has been approved and certified by the Wi-Fi Alliance, it will be listed on their website under the appropriate category as a certified product. So the process in a nutshell, as I said, you apply, you schedule with the test lab, testing gets done, reports are generated, test results submitted to the Wi-Fi Alliance. They do their administrative part, they review all the information, and if everything goes through smoothly, they will send you a notification, which is typically an email about the approval of the certification and instruction how to apply the logo, etc. Here are some of the examples to show different flavors of the Wi-Fi logo, as they are pretty much self-explanatory. If you look at an example on the top, that would be a logo for a device which will have 2.4 gigahertz and 5 gigahertz band, which means A, B, G, and N. The example down below cover a device at the very bottom for 5 gigahertz, which is A and N, and the one above would be a device which operates in 2.4 gigahertz band. So based on what the technology your device works on, what standard you are applying, there might be a slightly different flavor of the Wi-Fi logo you will be putting on your product. Here is a list. I'm pretty much reaching toward the end of my presentation. This is a brief summary of the key program where the Wi-Fi Alliance offers the certification program. The Wi-Fi Certified N been a very, very popular, a very commonly requested program. Wi-Fi 11 AC is a relatively new program, but there have been a lot of lots of interest into Wi-Fi 11 AC simply based on the industry trend. Some other programs which I would like to mention, they are at various different stages of the development, and there's still a lot of interest, and I believe moving forward in future we'll see certification program and interest in these programs as these technologies evolve more. One of the programs would be 802.11ad. This is the program which originally started as the Wi-Gig Alliance. However, later down the line, the Wi-Gig Alliance merged with the Wi-Fi Alliance, and this is being referred to as now 802.11ad. This particular technology operates at 60 gigahertz. Unlike 11N, 11AC, which operates at 2.4 and 5 gigahertz. 60 gigahertz spectrum, as it stands today, is not very saturated. So, excuse me. In other words, there are not many devices out there. Thereby, this spectrum is available for further, very widely available for further development. There's been a lot of interest there for, especially for high-speed video, high-definition video communication. There have been many products out in the market already, but it's a developing technology. It will be very interesting to see which direction this technology takes. And this technology is not going to, in my opinion, get rid of the 2.4 and 5 gigahertz Wi-Fi product. However, in my opinion, it will be complementing the technologies we have today, which operate at 2.4 and 5 gigahertz. Another interesting one would be the Wi-Fi HALO, which is a standard for IoT products. The challenge with the IoT products is that, for the folks who are not familiar with IoT, IoT stands for Internet of the Things, which basically is for very typically used for home automation, etc., etc. For example, in your home, you would want to control the lights in your home with your smartphone or the tablet, or you want to control the dimmer for the lights and or the fan. You want to control the video cameras within your home, or you want to have a security system installed. So you want to have an ability to lock and unlock the deadboards at your front door, or you would like to be notified if there's an intruder in the house, etc., etc. So all those different aspects of the home automation, whether it's security, whether it's just basic technology to control the lighting and stuff, all that will fall under the category of Internet of the Things. The challenge there is that these devices could be at the far end of the home, and your traditional Wi-Fi may not very easily be able to provide service there. So Wi-Fi Halo would be, by definition, would be operating at frequencies below 1 gigahertz. There is a talk about 1900 megahertz band, which allows low frequency signals to cover much larger area, and thereby, by definition, with little power, it can work more smoothly with sensors, wearable devices, etc., etc. So that will be a very neat use of technology in that frequency band, which will help complement the need in the IoT world there. So it will be interesting to see how this develops and how the new products come in the market. Finally, the Wi-Fi Vintage, it makes it easier for the user to select devices that give the best Wi-Fi experience in the airports, stadiums, offices, campuses, etc., etc. So these are some of the new evolving technologies. With that, folks, I would like to say thank you for your participation in the webinar today. My apologies for some of the technical difficulties we had at the beginning. It's unfortunate. However, time to time these things could happen, and I also would like to apologize for my my sore voice. I had a sore throat, and I hope I was able to do justice with this webinar, and I was able to speak clearly, and I was able to communicate some information which you folks may find useful. So with that, thank you very much. I appreciate your time, and I will hand the control back to our marketing team. Ryan, could you please take over?
Yeah, I hope you guys can hear me all right. Just a few follow-up things to that. This concludes the presentation portion of the webinar. So tomorrow will be
folks, it appears that we are still having some challenges on the technical side. I'm not sure if Ryan was able to take control. So I may not be able to address any question live on the phone simply because I am not seeing any. That being said, my request would be that if you folks have any questions, please email to the email address provided by our marketing team, and we will respond back to you with an email. Again, my apologies for the technical difficulties we had today. With that, I want to thank you again for your time, and have a very good day. Have a good day. Bye-bye.
So for anybody that is able to hear me, I'm not sure what our technical difficulties are. However, I have 2 questions here. For anybody that asked a question, I will follow up via email, and we will be making an archived copy of this webinar available on metlabs.com. So thank you for joining the webinar, and have a nice day.